Hi guys, Miss Zimmer here with our last lesson for this chapter, our lesson in circles, and this is the equation of a circle. Now, the equation is at the top. We have x minus h squared plus y minus k squared equals r squared, r being the radius, and hk being the center. So we have the center of our circle on a coordinate plane and the radius, and we plug those into that equation. Now, here are two equations that you're more familiar with. The first one being a linear equation. And remember, when we plug into a linear equation, x and y do not get replaced, not unless we're evaluating it. So x and y stay, and we put in the slope and the intercept. Same thing here. This is a quadratic equation that creates a parabola, and we replace a, b, and c, but the x does not. And sometimes we even write our y value in there, but usually you see that with x. So those equations I put in there so that you could see they don't get replaced. The x and y values do not get replaced in those. So we leave the x and y values in our equation of a circle alone as well. Now, beginning with our first example, it would ask, what is the standard equation of a circle? So this equation, and these are the notes that were in our section materials folder. If we have a center of 5, -2, and a radius of 7, then we would need to write the equation for our circle. So we begin with x minus, our x value is 5, squared, plus y minus, our k value is -2. So that our y value goes in with the y value there. And then our radius is 7. Now we have two things that we have to fix before we would type this into my math lab or before the equation was done. Nothing needs to be changed here. But we have a double negative, so we need to write that as +2 squared. And we also need to square the 7, 49. Obviously, you can do that as you're writing it, but I wanted you to see how it fits into the equation and then make those adjustments. You can make those adjustments right away while you're typing that into my math lab or writing it down. Now notice the signs here are positive, negative. The signs here, negative, positive. So when you're plugging it into the equation, the formula has subtraction signs or negative signs. So it will always be the opposite value of your point that is your center. So your k values when plugged in will always be opposite. Here's another one. What if we had a center of 0, 0 and a radius of the square root of 2? So our center, x minus 0 squared plus y minus 0 squared equals the square root of 2 squared. Well, you don't need to plug that into your calculator because we know if you have a radical squared, it's just the number. But what do we do here? Well, we know x minus 0 is x, and y minus 0 is y. So this one simplifies down, and it almost looks like a Pythagorean theorem problem, but it's not. It is a circle. We only have x squared and y squared when the center is at 0, 0. So that would be at the origin of the coordinate plane. All right, another example. If we have an equation given to us, and we are asked to go the other way. Actually, I should probably do one final one in that section. Let's say a center of 3, 5 and a diameter of 20. Let's do 12. Some of you that are following in the notes, you may note that I'm adding a couple of examples in or adjusting some examples. So our center is x minus 3, that's our h and our k value, squared plus y minus 5 squared equals, well, our radius isn't given, our diameter is. Our radius would be 6, so 6 squared. So our final answer, just instead of writing it again, this is already good. This would just need to be 36. All right, so if you're given a diameter, remember that's the radius squared, not the diameter squared. Typical mistake is just take the diameter and square it, but we don't square the diameter, we only square the radius. All right, I think I gave you 3 examples of how to just write the equation. Pretty simple, plugging in and making a couple of adjustments. Now, let's move on to one a little bit more complicated. We need an equation, but we're given these 2 points. The center is 1, -3, and we have a point on the circle, 2, 2. Well, at this point, at this situation, we notice, okay, I can do x minus 1, my center, hk, squared, plus y minus -3 squared, but I don't have a radius. So we need to deal with that missing radius. Well, we have a point on the circle, so consider this. If the center is 1, -3, and we have a point 2, 2, can't we find the radius? Distance formula. I knew you were looking forward to solving that again. Remember our distance formula tells us subtract our x values. Does not matter which one goes first. Subtract the x's and square, plus subtract the y values. Again, the order does not matter, and square it. Now, what I would do if I were you is I would put it into my calculator. I didn't even bring a calculator for this one, my apologies. Put it into your calculator, and what you will get when you do it correctly, let's say we've got 1 here and 25 here. You get the square root of 26. Now, this distance is your radius. You do not want to change that to a decimal, because what are we about to do? We're about to square it. So if you change it to a decimal and then you square it, it's not going to give you the 26 back. It'll give you some decimal sort of approximation, really close to 26, but not exactly 26. So now that we've done our distance formula and we have the square root of 26, now we can go back here and say, okay, my radius is the square root of 26, not 5, squared. And now make those adjustments that we normally do. And our radius squared is 26. All right, let's do another one like that. This time our center point will be 4, 3. And our point on the circle is -1, 1. So taking our equation, we have x minus 4 squared plus y minus 3 squared. But again, we need our radius. So taking those 2 points in our distance formula, but we know our distance will actually be our radius, so I'm going to put r. We do the square root, subtract our x values, 4 minus -1 squared, subtract your y values, 3 minus 1 squared, and add. So here we get 5 squared or 25. Here we get 2 squared or 4. So we get the square root of 29. If you were using your calculator, you can just put what's underneath the radical in your calculator and let it do the calculations for you. But make sure you put the square root of sign over it because that is your radius. So now when we plug in the square root of 29 squared, we have 29 for that radius. Everything else stays the same. All right, and that's our equation of a circle, our final answer. Next up. Okay, let's take an equation and let's find the center and let's graph it. I will apologize. I do not have a coordinate plane board at home, obviously, and so I'm going to have to hand draw some of these coordinate plane graphs. If you are printing up your notes, it may be a little bit easier to use those graphs on graph paper, but we may have to wing it, do a little hand graphs. Just make sure you count carefully. So here is an equation. This is actually a problem that is set up as a cell phone tower problem. And it says, when we make a call on a cell phone, a tower receives and transmits the call. A way to monitor the range of a cell tower system is to use equations of circles. Suppose the equation x minus 7 squared plus y plus 2 squared is equal to 64 represents the position and the transmission range of a cell tower. So we know a cell tower's transmission goes in a circle. What is the graph that shows the position and range of the tower? So essentially we need to graph the center and find the radius and graph that. Much easier on MyMathLab because you can just use a pull-out tool to graph your circle. And I left out a number. I left out this 2. That looks kind of weird. Well, first, we said our HK values are the opposite of what you see in the formula. So my center is not -7, +2. It would be +7, -2. So that's where I start on my graph. 1, 2, 3, 4, 5, 6, 7, and -2. So there's our center. Next, the radius squared is equal to 64. So the radius is the square root of 64, which we know is 8. So this is where it would be really helpful to have a coordinate plane board, but that's okay. Keep in mind that all the points that are 8 away from this circle, radius of 8, are points on the circle. But what we're going to do is we're just going to graph north, south, east, and west. We're just going to graph all of those 4 points. And then I'm going to freehand through those points. So we've got going up 1, 2, 3, 4, 5, 6, 7, 8. So about 8 this way. And then 1, 2, 3, 4, 5, 6, 7, 8. So about 8 this direction. And then 1, 2, 3, 4, 5, 6, 7, 8. About 8 that direction. 1, 2, 3, 4, 5, 6, 7, 8. Made it in this direction. So you can see all 4 of those points are relatively 8 blocks away. All right, not too bad. For a quick freehand, there would be our circle. On MyMathLab, you would either type in the center point and the radius, or you would use the tools that they have. You can practice with them, putting the center in place and then pulling the radius out and marking it, and it'll drop the circle there for you. You just need to know at least one of these points to sort of drop it in the right spot. All right, the next one. What are the center and radius of the circle? And this time, we have x minus 2, y minus 3 squared equals 100. So that means our center is at not -2, but +2, not -3, but +3. So 2, 3 is our center. And our radius squared is 100. So our radius is 10 when we take that square root of both sides, right? All right, so graphing. Again, we're going to go over 2 and up 1, 2, 3. So there is my center. Since my radius is 10, I'm going to be going around 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Wow, that was really close. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Below. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Off to that side, and 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So now I've got a pretty big circle. I think this one probably could be a little bit lower, but it's going to look a little egg-like this time because my freehand drawing was a little lacking on this one. Just a bit. Okay, close enough. So anyway, as you can see, again, the coordinate plane would be really helpful. But as long as you're going up, out, and over 10, I think I spread that one out a lot more. Okay. On to the next. Keep in mind, if they're asking you name the center and the radius, we've been naming the center and the radius and graphing it. This one will just name the center and the radius. Remember, if it says x squared plus y squared, your center is 0, 0, because there are no numbers being added or subtracted from the y or x values. So center is 0, 0. Your radius is equal to 4, right? Radius squared is equal to 4. So that radius is 2. The radius is 2. All right, moving on. Okay, I am in need of one more example that I did not bring with me, so bear with me as I make up a quick example really fast. There is a problem in your notes that we're not going to do. That's example number 6, so you don't have to worry about that. Let me go ahead and get some quick coordinates for one more situation that I know will appear in your problems. Okay. And then we'll move forward from there. Okay, let's say we have 2 points. Let's say we have 1, 0 for the center. Oh, not the center, excuse me. Let's say we have -2, 0, that's on the circle, and 4, 0. Okay, these 2 points are on the circle. One here, one here. These are the ends of a diameter. We need an equation. Well, I didn't give you the center. So the first thing we need to do is find the center. And I know you were looking forward to solving midpoint again. You get to do that. And you're looking forward to doing distance one more time. You get to do that. So first we need to find the midpoint. Well, I picked some really easy points. Some of you might already say, I know what it is by looking at it. I understand. But sometimes you won't be able to know what it is by looking at it. So let's go ahead and solve it using the midpoint formula. If we're looking for the midpoint or the center of the circle, we take the x values, add, and divide by 2. We take the y values, add, and divide by 2. So our midpoint or our center will be 2 divided by 2, 1, and 0 divided by 2, 0. Will be 1, 0. So now we have that center. Now to find a radius, we know that we need a center, we need a radius. To find the radius, we only need either these 2 points or these 2 points to use in our distance. So I'm just going to go ahead and discard this one and find the radius or our distance formula. 1 and 4, subtract those squared. And 0 minus 0, subtract those squared. Obviously, you could just leave that out because 0 minus 0 is 0, squared is 0. So that just goes away anyway. So we get negative 3 squared, which is 9, the square root of which is 3. So we have our radius of 3. Now going backward, we are ready to actually build back to the equation of our circle, x minus center value 1 squared plus y minus 0, which is y squared, because y minus 0 would be y. And then our radius, well, we have 3. 3 squared is 9. So the equation of the circle with these endpoints at the ends of a diameter would be, the equation would be x minus 1 squared plus y squared equals 9. Notice the center is at 1, 0. The radius is 3. I hope this has been helpful. Good luck on section 12.5, and hopefully I'll see you on Zoom for some question and answer help.